Hello everyone, welcome back. Today I'm going to be talking about dividing polynomials because if we know how to divide polynomials, that means that we'll be able to figure out how to factor these larger polynomials. Now, part of dividing polynomials to factor them involves knowing what a polynomial is divisible by, but we're actually not going to touch on that today. Today we're going to focus on the actual process of dividing polynomials specifically and what that's going to look like. So the method we're going to use is called long division. And yes, you heard me right. It's the same tactic we used, I think, in maybe first, second, or third or fourth grade to divide just numbers, right? If you recall from probably 10 years ago by now, or maybe more than 10 years ago, I'm not sure. If we did, 100 and then 5, it'd be like, okay, how many times is 5 going to 10? Oh, 2 times. What's 5 times 2? It's 10. And what's 10 minus 10? 0. Okay, then bring down the 0. How many times does 5 go into 0? 0 times. 5 times 0 is 0. 0 minus 0 is 0. So we have a remainder 0, and the answer is 20. We're going to use those exact same steps where we just multiply up, we subtract, bring down the next number, and so on for these polynomials as well. So it's as simple as that. It's just that we now have polynomial values in the mix here as opposed to just regular numbers. So with that little recall example aside, I'm going to show you what I'm talking about here. So here we're going to have x minus 3 out here, and then in our division, we're going to have 3x squared minus 3x cubed, not squared, 3x cubed minus 5x squared minus 7x minus 1. And actually, my division sign is too long, it turns out. There we go, that's better. Okay, so first question I'm going to ask is how many times does x go into 3x cubed? And the reason I'm looking at x is because, and not asking how many times does x minus 3 go into 3x cubed, is because we can deal with whatever the minus 3 brings us a bit later. Right now we're just focused on x because this is the highest degree in the polynomial that's over here, right? This is the highest degree, and we're starting with the highest degree of the polynomial inside our division sign. Okay, so let's go for it. So x times what is 3x cubed? Well, 3x squared. 3x squared times x is 3x cubed. So now let's multiply that. That's going to give us 3x cubed, and then we have minus 3 times 3x squared, which is going to give us minus 9x squared. And then I'm going to subtract. And keep in mind, when we subtract, we must put this subtraction sign. It must go through the distributive property, go through the rainbow rule for both of these. So we have 3x cubed minus 3x cubed, which of course is 0. And then we have negative 5x squared minus negative 9x squared, which is not negative 14x squared. It's going to be the same as negative 5x squared plus 9x squared, which is 4x squared. So this is actually going to be positive 4x squared. So do definitely watch that, because that's probably the most common mistake I see people making, is they forget that the negative, when we subtract, the negative must go through both parts to give us an accurate answer. And unfortunately, the sucky thing about dividing polynomials, or really any long division, is if you make one small mistake, then the entire answer from that point forward is going to be wrong, and that's very unfortunate. So we want to try and avoid that. Okay, then let's bring down the negative 7x. Okay, so now how many times does x go into 4x squared? Well, 4x times, so we'll add 4x here. So x times 4x is 4x squared, and negative 3 times 4x is negative 12x. And then we're going to subtract. So what is 4x squared minus 4x squared? Well, 0. And then what is negative 7 minus negative 12x? Well, that's going to be the same as negative 7x plus 12x, which is 5x. So that the answer is 5x. And then I'm going to bring down the negative 1. Okay, how many times how many times does x go into 5x? Well, 5 times, right? So plus 5. X times 5 is 5x. Negative 3 times 5 is negative 15. And then I'm going to subtract. So we're going to get 5x minus 5x, which gives us 0. And then negative 1 minus negative 15 is really negative 1 plus 15, which is 14. So our remainder is 14 when we do this division. So yeah, so the great thing with these, they're not very challenging in the sense that there's not really any challenging step or anything like that, which is good. I think the hard part for these is just that they're a bit long. They're a bit long and tedious, and sometimes it's easy to get mixed up if we're not focused. So it's important to keep practicing these steps, and it'll just get easier and easier as we go along. Okay, let's do a second example here. This one says positive 5x minus 2x cubed plus 3 plus x to the power of 4. So first things first, before we even write any of this down, I'm going to write this differently. I'm going to write this in a different order. I'm going to start with the highest degree polynomial part of this first, right? I'm going to start with, since this is a degree 4 polynomial, I'm going to start with the term with x to the power of 4 first, then the term with x to the power of 3, then the term with x cubed, then the term with x, then the term with the constant. So I'm going to put things in the proper order. Otherwise, when we try to do our long division, it'll get quite confusing. It's not going to make a lot of sense. So that's the first thing to always remember is put everything in the proper order, even if the question gives it to you in a not very good order, like they did here. So the order I'm going to put this in is I'm going to start with x to the power of 4, then negative 2x cubed. It doesn't look like there's any x squared, so I'm just going to write plus 0x squared as kind of a placeholder there to show that no, there is no x squared. Plus 5x is the next one, and then plus 3 at the very end. So there we go. Okay, then I'm going to put x squared plus 2x plus 1 right over here. All right. So let's do it. So how many times does x squared go into x to the power of 4? Well, x squared times x squared is x to the power of 4. Good. So what's x squared times x squared? It's x to the power of 4. What's 2x times x squared? It's going to be plus 2x cubed. Yeah, that's right, plus 2x cubed. And then what's 1 times x squared? That's going to be plus x squared. And now we're going to subtract. So x to the power of 4 minus x to the power of 4 is 0, so we can ignore that part. Negative 2x cubed minus 2x cubed is going to be negative 4x cubed. A lot of people would have just seen this and been like, oh, they cancel. But no, unfortunately, it's negative, a positive thing. And so it's just going to end up being negative 4x cubed. And then we have 0x squared minus x squared, which is just going to be minus x squared. Okay, and then we're going to bring down the plus 5x. Awesome. Okay, next part, how many times does x squared go into negative 4x cubed? Well, that's going to be negative 4x times. And then over here, we're going to get negative 4x cubed as we thought. And then 2x times negative 4x is negative 8x squared. And then 1 times negative 4x is negative 4x. And we're going to subtract those. So negative 4x cubed minus negative 4x cubed is just 0. Negative x squared minus negative 8x squared would be 7x squared. And then 5x minus negative 4x is really 5x plus 4x, which is 9x. And then we bring down the 3. Okay. All right, so now how many times does x squared go into 7x squared? Well, 7 times, so plus 7 up here. 2x times 7 is 14x. Ooh. And 1 times 7 is 7. So if we subtract those, we end up with 0 for 7x squared minus 7x squared. We end up with negative 5x for the second one for 9x minus 14x. And then for 3 minus 7, we end up with negative 4. So that's our remainder. So if we were to write this out, we would say that therefore 2x, or sorry, x squared plus 2x plus 1 times the answer we got, which on the top here, up here, the answer we got was x squared minus 4x plus 7, right? That's our answer. And then our remainder was minus 5x minus 4, so minus 5x minus 4 at the end there. So therefore, this would be our answer. Very good. All right, let's do one more example for this lesson. Here it says prove that 2x plus 3 is a factor of 6x cubed plus 5x squared minus 16x minus 15, and determine the other factors. So there is actually a remainder theorem to find that the remainder is 0 without actually doing the division. And if it just asked us to prove, it just said the first part, I think we should use that remainder theorem. I will be talking about that remainder theorem specifically later, but in this case, they want us to determine all other factors. So we're actually going to do a full long division, find the answer, and then factor that answer to find all the other factors as well. Now, in order to prove that 2x plus 3 is indeed a factor, well, what even is a factor of anything? A factor is something that when we divide, we get no remainder. We get remainder 0. So as soon as we can show that when we divide this, we get remainder 0, we have proven that there are no other, that there is no remainder, and therefore that it is a factor. And then to determine the other factors, we just factor our answer even further. And looks like we are doing division of a linear versus a cubic. And so when we find our answer, we'll get a quadratic. And sometimes quadratics can be fully be factored even further, right? Not all quadratics can be factored, I want to make that clear, but we need to check to see if the if that quadratic can be factored further into even different factors specifically. So let's do that. Okay. So let's go here. This is going to be 6x cubed plus 5x squared minus 16x minus 15. And then here we're going to have 2x plus 3. Okay. So how many times does 2x go into 6x cubed? Well, 3x squared times, right? What is 2x times 3x squared? That's going to be 6x cubed. Then we have 3 times 3x squared, which is 9x squared, like that. Then we're going to subtract. So we're going to end up with 5x squared minus 9x squared, which is negative 4x squared. And then we're going to bring down the negative 16x. How many times does 2x go into negative 4x squared? Well, I think negative 2x times. So negative 2x times 2x would be negative 4x squared. And then 3 times negative 2x would be negative 6x. And if we subtract, we're going to end up with 0 for this first one, and then negative 16x minus negative 6x, which is really plus 6x. So negative 16x plus 6x is minus 10x. And then we're going to bring down the negative 15. Okay. How many times does 2x go into negative 10x? Well, negative 5 times. 2x times negative 5 is negative 10x. And then 3 times negative 5 is negative 15. And so the remainder is 0. And therefore, we've proven it. So I'm just going to write a quick conclusion statement that states, since the remainder is 0, two x plus 3 is a factor of 6x cubed plus 5x squared minus 16x minus 15. So there we go. Awesome. Then it also says to determine the other factors. So we know that 6x cubed plus 5x squared minus 16x minus 15 is equal to 2x plus 3 times 3x squared minus 2x minus 5. But can we factor this further? So just going back to our grade 10 and grade 11 material, can we factor this further? And yes, we absolutely can. We can factor this down, in fact, to 3x minus 5 and then x plus 1. And so therefore, these are the two other factors. Therefore, all the factors of our original, of our 6x cubed plus 5x squared minus 16x minus 15 are 2x plus 3, which is our original one we were proving, 3x minus 5, and x plus 1. And there we go. That's pretty much that. Now, I do want to mention that in this course, you will need the prerequisite factor, the prerequisite skill of, especially for Unit 2 specifically, but just in general in this course, the prerequisite skill of knowing how to factor quadratics. So if it was confusing as to how I factored this quadratic here, do make sure to go review factoring quadratics in general, as that's a prerequisite topic. So I'm not going to go into detail here, but there are other sessions from grade 11 and grade 10 math where I do go over that. So if that is something you'd be interested in, please let me know. Okay, well, that is that for today with dividing polynomials. Next time, we will talk about factoring polynomials, which we actually did a little bit of today because in this third example, we did long division and then we also ended up factoring the polynomial as well. So it kind of ties into next day. Good work today, everyone, and we will see you next day. Bye, everyone.